Hey everybody, it's Mr. Morse. We're going to talk just a little bit about predicting products of chemical reactions based on reactants that were given. And we'll refer back to our notes or maybe to one of the most recent videos about types of chemical reactions. And just based on the reactants, we can tell what type of reaction we have, which helps us then write and predict the products correctly. So for this video, we're just going to cover synthesis, decomposition, and combustion. So we can get through those pretty quickly without a whole lot of extra work. We'll cover single and double replacement reactions here on the next couple of videos. So by looking at the three equations I have here, one is synthesis, one is decomposition, and one is combustion, I got to figure out which is which. So if I look back at my notes and just start from the beginning, I know in a synthesis reaction, I have usually two pretty simple elements that are going to combine to make one product. So if I look at my three choices, number one doesn't work because there's only one compound there. It's not an element. Number two doesn't work because even though there's two things, one of those two things is a compound. Number three does work because there's two things and they're each elements, calcium and iodine. So number three must be a synthesis. I'm just going to abbreviate that. Synth must be a synthesis reaction. So that's my first choice. Now let's just go ahead and classify these and then we'll predict some products. So our next choice is decomposition. So we know in decomposition we start with one reactant that breaks apart into simpler products. So if I look for my last two choices, it can't be number two because there's more than one reactant, but number one definitely works because there's only one reactant. And again, I'm just going to abbreviate that decomp for decomposition, which by process of elimination, number two has to be combustion. And if I look at my definition, it works because it's a hydrocarbon, so a compound that contains hydrogen and carbon, sure enough, reacting with oxygen, which is burning, and we call that combustion, which I'm just going to abbreviate COMB. So now we know what each type is. And now we have to predict the products. So let's just start with number one. We know in decomposition we have one reactant that breaks apart into two simpler products, usually just two elements. So in this case we'll break apart into the two elements we're made up of, which are nickel and chlorine. And then the only other thing I have to do before I balance this equation is say, hey, I have two elements that are by themselves. Are either one of these a diatomic element? There's those 7 elements that we call the Hofsprinkles that always come hooked in pairs because they're so reactive. So I check. Nickel, nope, not a Hofbrinkel, not a diatomic element. Chlorine, Hofbrinkel, yes it is. It's one of the diatomic elements, so I got to put a 2 after it because it always comes in pairs. And the last thing I can do is go back if I want and add coefficients in front of each part of my equation to balance. For now we're going to skip that so we can just talk about how we write the products. And then we can always come back and balance it to practice later on. So for the next one, we have a combustion reaction. We have a hydrocarbon reacting with oxygen from the air. And this one, because it's a combustion reaction, the products are actually really easy to predict because in every combustion reaction ever, for now for us, the products are always going to be carbon dioxide and water. So again, combustion is burning. We're going to make CO2 and water, which are both vapors or gases. They're going to float off into the air. But it's always, no matter what I start with, if it's a combustion reaction, the product's going to be CO2 and H2O. And then last but not least, our synthesis reaction, we have two simple elements combining to make one compound. So we have calcium and iodine going together. So I write the formula for that compound. And then I do need to check charges. This is an ionic compound. So I go to my periodic table and I find out that calcium is a 2+ ion. That iodine is a 1- ion. So that means that I'm going to need 2 iodines so that my charges are balanced and my formula is written correctly, which means I have to add that little subscript of 2 right here to make this formula correct. And then when I go back and balance it, that actually is going to help me out. So in terms of synthesis, decomposition, and combustion, fairly easy to do once you practice them. Once I notice which one is which, the products aren't too bad to write. The biggest thing is that for anytime I have single elements, like this chlorine right here, I got to check to see if they're diatomic, if they're one of the Hofbrinkels, and if so, I need 2 of them. And the other thing is anytime I make a compound like this guy right here, I got to make sure that the charges are balanced, and if not, I'm going to add a subscript like that little 2 to make that happen and write that formula correctly.